Good morning. I'm
Good
Sarabjit Singh,
morning.
and I'm from Fateh Rural, Mumbai, and I've passed out in 1998 instrumentation from SLIET. Welcome to this podcast of SLIET Alumni Association. Sorry, there was some link issues because of that. It has delayed by around 30 seconds. So, as far as my introduction is concerned, I am into entrepreneurship from the last almost 20 plus years, and I have been running my own company since day one. I have never worked anywhere as an employee, so I don't know their difficulties of employees much. But anyhow, I do understand this is a jokes apart. So the thing is, we are running a company called Fateh Rural Private Limited, which is into advertising and marketing in rural India. We have 10 regional offices across the country, and we are catering to around 100 plus corporate clients. And we have multiple services, including call centers, including outdoor services, ATL, ETL, printing, events. We are into almost all sorts of marketing activities across the country. And as far as our presence is concerned, we are present pan India. Even we have a call center and an office in Kashmir in Sopore as well. And we have in South India, we work till Tamil Nadu, South India. So in a way, we work from south to north and east to west. So that's my introduction. Onwards, I'll be introducing you Mr. Hani Jindal. Sorry, Pushpinder Hani Jindal. So Pushpinder ji has been working with food industry from the last 16 plus years, and he is very experienced working in the one of the largest companies in the world, and he has portfolio including technologies to handling vendors to handling government departments to almost everything. So I think Pushpinder ji will be able to tell about himself much more. Yes, Pushpinder ji, please welcome.
Yeah, Sarabjit ji, thank you. Thanks for this opportunity. Hi everyone. I am Pushpinder. I passed out from SLIET in 2005 from food technology. Thereafter, I had my post graduation, and presently I am with Mars International, and taking care the technical part at plant at Baddi. I've been into production, capital projects, energies, and all sort of plant operations. And being the part of leadership team members, I have to handle all the associate related and the company policies from the future standpoint. Personal interest is I must say that I am being into energy optimization, be it of water savings, boiler, steam, and all. So, not taking much of time, the very purpose for which we are here today, I'm handing over to our, worthy Professor DC Saxena. Over to you, sir, and let's we all learn from their experiences. Yeah.
Okay, thank you, Pushpinder, and thank you, Sarabjit ji. It's really a very nice platform to be attached with all of you, maybe my students and my uh, colleagues also as a teacher, those who have joined this channel. So really, I am very happy to share my views over this. But as a customary, I must introduce myself. So I am Professor DC Saxena, and I joined this flight in 1999. So almost 24 years are over, and I have done my BTech and MTech from HBTI Kanpur in 1988 and then 1990. Then, after I have completed my PhD from CFTRI Mysore, that is a very premier institute and number one in Asia, particularly for food technology. So, in that way, I am really blessed a teacher, I must say, that I got my education from very reputed institute. And as far as my career is concerned, so till now, about 18 students have completed their PhD degree under my supervision, and about 30 students they have completed their MTech thesis, and many more BTech students. And recently, on 1st May, this patent has been granted to my team, I must say, because this work has been done by one of my PhD student who has worked very hard to develop this technology. And I must say that work was not simple. So this was my little bit introduction, and I have also worked as Dean Planning and Development, Dean Student Welfare, and in almost every section of SLIET Longoval I have worked with, except the director, of course. So in that way, I am very lucky also that I joined this institute, and this has given us a very good platform to work with, to liaison with industry, to liaison with other sections of the government. So in that way, we are free to do any type of work related to academic as well as for extracurricular activities also. So then I'll come to the main point of this today's uh, live show at a YouTube channel. This work, I must tell you that we had to work very hard because this material is totally different. If you talk about the plastic industry, shall I open the slide one? Can you start the slide?
Sarabjit sir, you're on mute.
Slide is, yeah, slide is open. It is visible, sir.
It is. I want to just change the slide.
You want
It
to
is
go to
not.
next one?
Yeah. Yeah. So this work, the genesis of this work, I want to tell you because nowadays everybody is concerned about the environment, whether it may be flat, whether it may be house or bungalow or anything else. Means we want to plant some trees, we want to plant some saplings just to make our environment green and healthy. And now then, whether you open Amazon, whether you open Flipkart or any other site, they may be advertising for the indoor plant, for the outdoor plants, just to make the atmosphere healthy. So in that way, I'm also a very plant lover. So I went into that direction, and I was thinking when I was carrying some sapling from nursery or some from any other site, we were bringing the small sapling either in the plastic packaging or in the plastic container or some in some other plastic one. And while planting those sapling into our bigger plot or in land, we used to throw that packaging into the dustbin. But that work is not over by then because that plastic goes into the cycle and that is creating some problem. And another aspect, because of that plastic packaging or the plastic container, the plants they are experiencing some planting shocks. Their roots are encircling into the pot itself. They may not be getting the proper space to grow with. And when we plant those sapling into our bigger plants or in land, they may have some shocks, transplanting shocks, because they are not used to that. And because of that, the quality or the life of the plant is reduced. So, by keeping into that mind, we have developed this technology that I will come later on. But first, I will try to speak about some little bit known facts which may be known, but which are very important to create awareness among ourselves. So, I'll be covering this small topics like agro and food industry waste, alarming agro and food industry issues and effects, waste management, then utilization of agro and food industrial waste, and use of these waste for development of different molded products. Then, what are the economical aspects? And finally, the concluding remarks. So this is about the organic waste from where we are getting our waste. That may be categorized into two types, agriculture waste and the food waste. So in agriculture waste, we may be having crop residues, husk, rice, that paddy husk, that wheat, then hulls of barley and some other crops, then leaves, then vegetable matter. And from food waste, these food waste we are getting from different industries like food and drink manufacturing, then from grocery, from catering business, and obviously from consumer, which is having lot of household waste. So these organic waste we are getting from different sources. And these are some alarming issues related to agro or food waste. These two pictures you can see very clearly, and the effect of these pictures have been in news for so many years. There are so many committees, there are so many issues, farmers' issues also, administrative issues also. So they produce a large amount of waste annually. But this burning, dumping, or unplanned landfilling, they are the traditional ones, just to get rid of this organic waste. But this is not a permanent solution. And these management measures, they create problems. Global warming, now everybody is seeing that. Now even Europe is also facing scorching heat. That was not earlier. It is because of only the global warming, which has been produced by increasing the amount as well as number of so many other greenhouses gases. And it is not limited to locality now. This farm, this burning, this crop residue, now this is now this is affecting the major areas of India. The heat of it, whether it is in Punjab or Haryana, the heat of it can be felt by the Delites, by the Noida person, by the UP person. Okay, so this is a very
So, sir, there
burning
is a
issue.
comment from Gaurav Chatwal. He says, great profile, Dr. Saxena. Slide is blessed to have teachers like him to guide students. Must say that students should take advantage of Dr. Saxena teaching experience.
Thank you, Gaurav. Thank you, Gaurav. So, and we have to understand these sources, means what are their contribution. We can see here the residue sources, they have major chunks of cereals. 70% of residue sources we are getting from cereals, then fiber crops 13%, pulses, sugar cane, oil seed, and some other sources. And this crop, I want to go full. Yes. Now, these crop residue, which is about 686 metric tons per year, burn waste, that is 92 metric tons per year, yeah, and which can be utilized as fodder as well as manure or the building material, that is in the very high amount, that is 343 metric tons per year, and some crop residue which can be unutilized, that is also a very big chunk, that is 251 metric ton. Now, the share of these unutilized residues, which is generating the total residues percentage wise, we can see here cereal again that are having a very great chunk, 58%. So now we can see the importance of crop residue from cereals. And that is why this burning issues are coming in Punjab, Haryana, and some western UP parts. So particularly in India, that is about 40% of the food produced is wasted. That is 21 million tons of wheat that is wasted in India, maybe in the silos, maybe because of some wrong policies, maybe because of some unawareness. And according to the Ministry of Agriculture sources, about 50,000 crores worth of food produce is wasted annually. So we can take advantage of this amount. And even USA that produces 1.3 billion tons of waste a year, which is the estimated cost is $165 billion. So now not only in India but USA also and some other countries also, although they are having very strict rules, very good governance, but because of that, they are also not able to reduce this waste. So just to show the role of decomposer in waste management, in livestock waste, this agriculture waste, then we are having industrial processing waste and post-harvesting waste. So here we can utilize the decomposer, which can decompose the waste in a very effective manner. is how we can go for valorization or the utilization of food and agricultural waste. So in the wastewater treatment, we can produce biodiesel from different crops, and we can extract the phytochemicals, we can extract the biocatalyst, and that can be used in different process. So this is about the agriculture or the agro-industrial waste valorization. In these ways, we can utilize our waste. There are different waste management function, and those who are in industry, they can very well understand, I mean, what type of steps these are just to manage the waste out of the agro industry. So from production, then we have to collect the waste, then it can be transferred either to storage for further use, or it can be treated for immediate use, and in that way we can utilize this agro industrial waste. So types of farm waste. In previous slide also, I have considered this type of waste. So it can be processing household hazardous waste also. So that has to be separated from the other types of waste, which are animal and crop waste. These are some of the examples from where the waste is generated from some of the food industry. Means the processing sector like onion peels, that is also a waste material. Rice straw, wheat straw, we know very well. Then pomegranate peels and poultry waste. Then cattle dung waste, sugarcane waste, vegetables and fruits. But in my opinion, we should not call it waste unless until we are able to utilize it. If it can be utilized, then we should not call it a waste material. Okay. These are some figures about the different residues coming from different sources like oilseed, fiber crops, pulses, sugarcane, and again you can see the cereal crops that produces residues in a very large manner. So we are having a very great opportunity to utilize the waste residues from cereal crops. We have to see the opportunity. And this is about the recycled value added application of different agro industrial waste. So this is just like a suggestion where we can use these type of waste, like in citric acid production, enzyme production, biofuel production. In pigment production, we can extract different types of pigment. Then in producing biodegradable polymeric system production, bioactive compound, as I have told you earlier also, and we can extract different food flavors from this waste. And finally, these can be used in agriculture composting.
So, Dr. Saab, there is a question regarding as you have mentioned, it can be converted into multiple, it can be used in a multiple ways. Can our institute or the faculty or the PhD guys from our institute can help some entrepreneurs, or can any model be built in order to start such kind of productions?
Why not, sir? Why not?
Okay,
They should come to our institute. We are always open. And
okay.
the patent I got for that particular technology, I'll be discussing just after 2 or 3 slides. So these types of techniques that can be very useful for any type of industry. And I must admit, I must admit, because as an academician, we are not having that much channel to commercialize the technology. So in that way, the platform you have created, that would be very helpful. Because maybe in terms of our students and their colleagues, we are having very good sources of industrialists, and we can provide the technology, but it is our limitation that we cannot transform that technology for larger scale production. So there comes
Of course, that needs an industry. Of course, you need industry in order to support that. But if somebody comes in order to put in money, and they want to establish something, then they might be needing experts in order to guide them, in order to
yes,
build the overall infrastructure and then start producing. Of course, so in that case, if it is coming up, that is great.
Yes.
So there is one
We
more.
welcome.
Vivek Singh is saying great knowledge session.
So I
So
hope
people
it
are
would be
watching. Yeah.
it would be beneficial for all of us. And
Yes. Dr.
yeah, I
Kulvinder Maan is showing thumbs up to you, Doctor.
so let's continue my lecture. I'm very happy.
Yes, sir.
Uh, so waste management, I don't want to tell each and everything about it because we are having already so many industrialists. But the first priority should be to reduce the quantity. Unless and until we reduce the quantity of waste, we are not going to prosper in any way. Next step is to reuse the generated waste. I think I'll go to the next slide that will be much more explainable. So this is the uh, means desirable pattern of the waste management. So the most desirable pattern is to reduce the quantity of waste. That should be the prime concern of our efforts. Okay. But if we are not able to reduce the waste, then only we should go for reuse it. Example I would give you, everybody is saying that we should ban plastic, that pack, we should ban plastic material like that. But if we are able to reuse it, I think we are reusing those uh, that plastic bags for so many times unless and until it is not worn and torn. Okay, so
Yes,
we have to admit that. So we are reusing it, and if we are able to reuse those waste, that is much more beneficial if we are not able to reduce the quantity. Then in the next step, if we are not able to reduce the quantity, we are not able to reuse that after so many efforts, after so many times of use, then we can go for recycle. There is another opportunity. We can recycle that product to make different new products. Like we can see that compost one that is also recycled in the natural cycle. And if we are not able to recycle, or if there are something is left over after adopting these three steps, reduce, reuse, and recycle, we can recover the important components from that waste. Like we are extracting, we are recovering the energy from the paddy husk, from the wheat bran, and from some other stubbles. Okay, then we can extract different bioactive compounds that are much more costlier than the main product. That is the beauty of extracting the bioactive compound. Those are very costly, and we can extract the metal also, because I was involved in some of the project along with Dr. Dheeraj Sood from our chemistry department. I was co-PI of that project. So that project is to extract the metal from the wastewater which is flowing in the Ludhiana estates from jewelers. From different dwellers, there are some drains and they are draining that water. Even that water can be used for extracting precious metals. So that was the
great.
project, that was the good one. And finally, if we are not able to reduce, reuse, recycle, or recover, finally it comes to the disposal. That should be the least desirable effort of this waste management cycle. And not only disposal, that should be the safe disposal that can be used in the landfill or for any other purpose. So this is one of the method to convert the waste to biofuel. I'm not going into detail this cycle. That is very scientific one. Okay. Another one, which is the main topic of my lecture, is to utilize this waste for manufacturing different molded products. So in that line, I must say that first we have to collect the waste material, then to dry that, then to grind it, because we want to use that particular waste material into a powder form. And if we are able to recover some important bioactive compounds or some other compounds, like we have to remove the fat or oil or any other recoverable component which is very easy to recover. I'm not in favor to add the cost in the recovering process as compared to the main material. Then we have to add some plasticizer because these are very important component. Because of that, because of absence of that plasticizer, it is not able to bind the material. So plasticizer is having a very important material. And in our patent, we have used the plasticizer that was very cheap one also as compared to glycerol that is very costly. So we have utilized all the very cheap material just to get this product developed. And finally, the molding to get the final product and extruding to develop the pellets for which I got this patent into different shapes. And finally, drying should be done to store this product in a safe manner. This is all about the previous one, means this extraction of this important bioactive compounds. They are very advisable for increased earning. In addition to that, and some polymeric remains like this this hemicelluloses, they may be having some ability to contribute in a very rigid, stiff, and self-stable structure because of this cross-linking. And to increase this cross-linking, some compound like sodium alginate or other compounds like I have mentioned, the glycerol or the cashew nut shell liquid, so that can be used for effective cross-linking. And the CNSL, that is cashew nut shell liquid, some other hydrocolloids, they are in use uh, for this enhanced binding. So thank you, Sanjeev Gupta ji,
There
for
is an
your.
option come up from Sanjeev Gupta ji. He says really a very hot topic for current situation, particularly in North India. Already ran a unit of biofuel briquettes from 1998 to 2005. Can start a new venture with the help of Dr. Saxena. You
Oh,
have an offer, Dr. Saab. Congratulations.
yeah, thank you. You are
So I
almost
will, Sanjeev
you
ji,
are,
I will give you this number. Dr. Saab's number is available on the things, and if you want to contact him, certainly I have your number as well. So I believe you should contact with each other. And if I'm not wrong, Sanjeev ji is based in Abor only, so he can visit your place. He
okay.
is
Yeah,
a master businessman from day one. He has been into business,
yeah,
so
Sanjeev
you
ji,
can
you
connect
are
with him.
always welcome to visit your institute, not my institute, your institute only, and we can interact in a better way. So I'll go for the next slide. Yeah, this is about the product what we have developed. So we have taken this banana peels from local juice vendors and this
Okay.
paddy husk. These potato peels, I have shown these potato peels, but we have taken potato peels from the PepsiCo industry, which are producing this potato chips. So they are producing a very large amount of potato peels, which are means taken into account for animal feed or for some other uses. So we have taken this potato peel from them only. Then de-oiled rice bran, that is a very important component of this solvent extraction plant in Dhuri.
Yes.
One industry like AP Solvex industry, they are producing a lot this rice bran oil, and after extracting rice bran oil, they are producing this de-oiled rice bran in a powder form. It is not in the form of cake, so it is in the powder form. So we are using this de-oiled rice bran in producing the this biodegradable planting pots. Sorry, this previous one. Just a minute. How to go to previous one?
Previous. Okay.
Previous one. It is not previous one, sir.
This one, sir.
Previous one. No, no. Okay. Left. Previous. Just
Which
one.
slide number?
19. 19. After that. After that.
Okay.
Yeah, this one
Is
only.
that
Yes.
okay?
Yeah, that's okay. So on this side, you can see here, because of this environmental pollution, transplanting shock, which I have described earlier, and this plastic packs where this saplings are there, they are impermeable to the this roots and all, and there are so many economical concerns also. And obviously this we are doing just for the waste utilization purpose. So you can see here at the bottom of the slide, the encircling of roots inside the packing. Because of that impermeable packing, this encircling of roots takes place, and that is a planting shock. And on the right side, you can see the CNSL, that is the cashew nut shell liquid. Again, it is a byproduct of that cashew nut industry. Glycerol also we have used, but glycerol is a little bit costly as compared to CNSL. So for that purpose, we have made different permutation combination on the trial basis. So our main purpose was to use the cheap materials, waste material. That is why we have used in our most of the formulation this CNSL. And on the bottom right corner, you can see roots and circling pods. So because this is their tendency to grow, but because of that impermeable nature of the plastic pods, they are not able to come out of the pod, but they are encircling and they are coming at the bottom. So they may not grow well as they should be. So this is the recycling economy, I must say. You can see we can start from top left corner, crops. From there, we have taken this de-oiled rice bran, then raw material from food industry waste, explained in our previous slide. Then we have used this cashew nut shell liquid as a binder or as a plasticizer. We went for extrusion, which is a very popular machine, a very wonderful machine. There, means, by formulating different components as well as different processing parameters in extruder, like feed hopper speed, feed rate, then screw speed, then temperature at different zones, as well as the cutting speed. So many processing parameters we have optimized, and after optimizing those conditions and on the basis of different responses or the desirable properties of pellets, we could be able to produce these pellets as shown in the bottom picture. And as you must have some knowledge, some observation about the plastic grains which are being used to produce our normal plastic daily use components, like this plastic baskets and any other plastic material like container. There they use plastic grains, small grains, that shape of some rice or in cylindrical shape. They use this plastic. It is known as plastic dana in the commercial terms, in
Right.
industrial terms. So there they use plastic dana for making the different molding products. And because of it is, since it is a plastic, it can be stored for a very long time. So that thing happened to our mind also, that if we can produce the pellets which can be stored for a very long time before utilizing it for making any molded products, that would be far better as compared to the plastic that plastic grains. And by keeping those qualities in mind, we have optimized the pellets for maximum bulk density and minimum expansion ratio. So those two things were the most important parameter, and on that basis we have produced these pellets, which can be stored for a year or so in a suitable storage condition. Finally, those pellets, we went for this injection molding, but it is not that easy, because the injection molding machine which are available in India or in industry, that are being used only for the plastic grains. But our pellets, they are mostly organic material, and if we go a higher temperature beyond some certain limit, that will burn. So that will not melt, but that will burn. So for that purpose, we have to go for certain temperature range, and for that many studies were needed, like the thermogravimetric analysis and some other studies also, so that this can melt. This pellet can melt, and that is not very easy task. And I think for that purpose only we got this patent, because to produce this pellet, and they should melt at some particular temperature, because that melting point is very higher. But if we go to a higher temperature, they will burn. So we have to compromise for some threshold value. And the normal nozzle which is being used in these injection molding machines, they are not suitable for our product, for the organic product. Yeah, pellet should melt at some temperature. But because of this, it is an organic matter. It is a completely organic matter. It may burn. So for that, we have to design one nozzle. We have designed already that small nozzle. So that can be used only for this injection molding technique. That is one of the important parameter, one of the important, you can say, effort, I must say, in her studies, particularly of my that student. So we had to design one nozzle for this purpose. And finally, we went for this injection molding technique. There we have optimized temperature at different zones. We have designed one mold of this pot shape, and that also we have to design. We have to standardize one thickness of the pot, because beyond one it will have more weight, it will have more material, so that will be more costlier. And for that we have to design some other parameters also in the machine. And means lesser than that limit, lesser than that thickness of the pot, that will be very brittle, that will not have particular strength. So we have worked on that optimum thickness of the pot, so that it should not means it should not go for fragment very easily, and it should not have that much very means a large amount of material also. So for that means we have done so many optimization studies. So finally we could develop these pots. And the right side of these two pots, where a plant is already there in the pot, that is the actual one that I have grown into my home in that developed pot. Okay, and that pot you can see here, that was in the degrading stage, and after degradation in the soil, after a month, I mean, that was completely degraded in the soil. So that
Oh,
has no leftover issue. So finally, from where we have taken our raw material, it finally merged with the nature. From where we have taken, we have returned to that nature also. So that is the beauty of this project. Okay.
so Dr. Saab, what was the approximate cost for this one pot which you have created, if you have
Yeah.
calculated?
Yeah, based on our study, we have calculated that the pot made up of glycerol as a binder, that may cost about 15 to 16 rupees per pot, and
Okay,
yeah, per pot, single pot, single
I got
piece.
it.
Yeah, and if we use the CNSL, that is the very cheap material, so that cost will come between 10 to 11 rupees only,
Very
not
good,
much.
superb, superb.
Yes.
So,
So
so in
these
a way,
are,
it is quite cheap it is easily sellable in the market. Then.
yeah, I must say it is cheap, but it is more beneficial if we talk about the
Yeah, both
environmental.
ways, na? Both
Yes.
ways. It is economically also very beneficial.
Yeah. So these are some of the factors which are means desirable in producing the pellets. Also, these are of the some scientific nature, but these are very important. Like this SME, our mechanical engineering student, they may know better what is the SME, specific mechanical energy. Then color, expansion ratio, pellet durability index, hardness of that, water binding capacity, water solubility index, then drag coefficient, terminal velocity, coefficient of friction, and angle of repose. These are some of the factors which are required in handling the pellets from flowing out of the hopper. So all these concerns we have taken into consideration. Then obviously that bulk density and tapped as well as loose. and the Hausner ratio, which is an indication for flowness of the material. These are some important parameters which are important for this developing the pellets. So, what are the economic advantage of this? Is the real pot what we have developed, and this is the real plant which I have grown into my home. Okay, so this accelerates the cultivation as well as growth, but the reduction in pot size as compared to the plastic pot to obtain a finished plant of the same size. These are some limitations. Plastic plant can be developed in any size and any shape, but here we are having some limitation because beyond that particular size, we cannot develop that because that will not have that much strength. Okay. Then advantage is speed of repotting or planting. So we don't have any need to remove the plant from the pot and throw it. It
So
can
you
be
can just put in. Okay.
yes, we can directly put it into the bigger plot or in the soil. So there is no need for means collecting the plastic pots, means elimination of time in the collecting plastic pots. No need to put labor on that, and there is no cost for recycling one. But the organic pots are little more expensive than their plastic cousin. That is limitation, a little more. But the
And
labor
secondly, there is
saving,
a lesser chance of plant death. The plant
yeah,
will remain there. There is lesser chance.
exactly. So this labor saving as well as the plant productivity that will make up for the few extra cost per pot. So this commercial landscapers, that is a very means you can say what happened. Okay, no problem. So this they can expect a 20% savings in labor
Okay.
because there is an elimination of this time for collecting this waste and all, and which is very important consideration where we'll go for the commercial commercial means the development of this plot, this particular pot. Okay. So these are some of the studies. Means the strength of the pot is very important. So these are different combinations. You can say, and under different storage conditions, we have studied means for how long they can be stable. So this is effect of temperature, plasticizer, also storage condition, also upon the strength of the pellet. So I'm not going into this detail. These are some of the parameters which should be taken into consideration in the development of pot. I mean, what are their structural changes? They should not change their structure. The breaking strength, they should have greater breaking strength. Permeability is important, but they should not be permeable to the from out to in. Okay, and they should have water absorption index, good water absorption index, so they can absorb the water. Otherwise, soil will not into the contact of water. And water solubility index also is an important parameter in the development of these pots. And dipping time, because water is an essential part of any plant. So we have done some studies on the water uptake of these biodegradable pots with different formulations, means how much water it can uptake and it can hold its strength. That is much more important. Then weight loss on water strength, because it is absorbing some water, but because of that water, it should not decompose itself up to a certain limit. So that study is also. Yeah, there is some question from Pushpinder ji. What is
Pushpinder
the
ji, for you, there is a question. What is the current scenario going on in market for food technology, especially UG students?
I'll must say that there is always an opportunities. Important is how we present. There are vacancies in the industries. Important is right pitching and with going with that I'll say the content over there. People must study wherever they wanted to go. Must study what they present to that industry, but into that factory, so that they can take it up easily.
Even Dr. Saab can answer that. Yeah, Dr. Saxena is already with UG students.
Yeah, there are a lot of opportunity for UG students, and as I can see about 5 or 6 years uh, older batches of particular about food technology students, they are in very good position, like our Pushpinder Hani and one of my MTech student Paramdeep as Ghuman and so many other students. They are very top position and very good position. Only thing, we should not compare the salary package with the computer science students, those who can get very high package. But after 2 or 3 years, the food technology students, they can they can go to a higher post, higher designation, and because of their hard work, because there is a lot of opportunity in the manufacturing sector.
But I think food guys can even start their own companies. Food is
Exactly.
having such a
Yes.
high scope,
Yes.
and this is something really, really important that everybody have to eat at least 3 times a day. So
Very
if you are able to create something really useful and you are able to cater only one or two cities only, I think people can do really well.
yes.
Yes,
That is true.
yes, yes, absolutely. And I just wanted to add one more point.
Pushpinderji, your video is off, I think.
As the- yeah, actually, I'm driving right now and I'm managing low network, hence I kept
Okay,
my
okay, no problem.
off. My point is just I want to add is that like I got a call from one of the student. I would not name. He got the opportunity in probably Pillsbury or some good company in Mumbai, but the entry package is low. At this moment, a student do not worried about the packaging. Just think about that they are getting paid for their expenses and you are getting experiences into those industries or platform, the biggest lab, I'll must say. In a year or so, the package will follow you once you will that proven your battle to the industry. So at the entry level, we are not from IITs, we are not like CFTRI and all, but nowhere I am downsizing my college. Important to understand is that let me experience and then to pitch it to the industries. Any opportunity if comes, please grab that. And to Puri sir, definitely the entrepreneurship is a boom now, and it's the right time to enter into the entrepreneurship.
Right, right, right. Yes,
Okay.
Dr. Saab, you can continue. Yeah, there were
Yeah.
some questions which
So there's a slide I want to talk about a little bit. What is the effect of formulation? These are different formulation which has been studied for the effect of water resistance of pots. Means how much water it can take, how much resistance it can show to the water, because the storage condition may be different. In the rainy season, it may be very difficult to save from these spots from rain. So in that also we have taken all the practical aspects of storage, because these are not going to be stored under the cold storage or refrigerator or freezer. These are the very practical events, since it is a very means product from very cheap material. So we don't want to increase the cost. So because of that, under the normal condition, what should be the impact of this environment condition on these pots? We have studied different aspects. So this is about the weight loss under the different storage condition with different formulation and along with time. So this was about the formulation effect on strength of the pots. So we can see here under different conditions, the strength is getting down under different conditions. But this is not the dry state. These are different states of storage only. These are not like that. Okay. Yes, breakage height is
are.
very important because these can be
There is
thrown during
one more question. Cost of pellets per kg.
Uh, I'm really sorry. We have not means considered
Calculate.
that cost of pellets. Yeah, we have not calculated particularly, but we have calculated the cost of pots only, final product. Okay. But we can
Okay.
calculate. And Sanjeev Gupta, you please share your number with us, so I can tell you the exact calculation.
But there
So
is one
this,
more question. Question
yes,
is, can we make other things also other than pots, like any usable plates or something like that?
yes, yes, exactly, exactly.
So is it
Only
washable and all?
it can be made washable. For that, we have to add a small edible layer of amylose.
Okay.
Amylose layer. Amylose is extracted from starch, so that can be added so that otherwise it will uptake the water.
Okay.
That's the problem. So we can work on that.
So in a way, utensils can be made which can be used, let us say 1 year or 2 years for.
Yes, yes.
Then
For
they
that,
can be changed.
yeah, for that we have to change a little bit formulation because
Okay.
in
But it
this
is
study
possible.
it is possible. It is possible. I will show. I will show you some slides at the later stage. That will be
Okay.
clear. So this breakage height is also very important. This drop test, because during handling, it can be thrown from a height. So it is an important parameter. Then biodegradability. That is the most important factor in our study. So these were based on that, and as you can see on the right side of this, different stages of biodegradation. In earlier stages, then this one, and the second one, and this one, and finally, it will merge with the soil from where it has taken. And number of days at different formulation. So 60 days, then 80 days, 100 days, and 120 days. So you can see here the effect of plasticizer, that glycerol and the cashew shell liquid in different formulation. So it can store for a number of days, pot itself. This is the effect of plasticizer on biodegradability. And for that, this release of CO2, that is, this study is for another patent actually. We have devised some equipment on the basis of this, because in biodegradation, usually it is not part of this particular study, but I would like to tell you, we have to dug out that particular material after 1 month time or 15-month time. Then we have to see whether this has been degraded up to a certain strength or not. So for just to overcome that problem, we have devised some equipment, and based on that, we have measured the carbon dioxide out of that pot directly under the same soil condition. So on that basis of the release of carbon dioxide, we can say that how much biodegradation has taken place in number of days. So this was the figure from some other products from some other countries. So these are the pots made from straw. You can see here I have taken this picture from internet, but I'm not sure whether this is the actual one or not, because the finish is very good, and I don't think that this finish we can get from this biodegradable material. So here natural latex has been used as a binder. These are some this cutleries or this small plates, and that can be made from. These are in use particularly. Agro waste like rice straw. So this semi-solid substance is dried. Any other commercial products which can be produced other than pots? Yes, I think
These
we
are the
have
answers. Yeah.
already answered this question. These mushroom walls taken from internet, mycelium type of bacteria which is placed in mold with tree trunks and agricultural byproducts. So within a couple of days, this matter it goes to the desired shape. If this shape is dried in oven to stop bacterial activity, so this can replace traditional insulating and packing materials. Here, I would like to add that I have been granted a project from AICTE to develop the aerogel, that is a type of packaging material from the waste material. We have extracted starch from the unconventional sources, crops, and that starch has been modified to form the aerogel, just like a packaging material. So that is the project we have just received in month of May from AICTE. So we are working on that. This the pot they have developed from hemp fiber using the sodium alginate as a means effective cross-linking this factor, the binder. Okay. Some of the pots they have developed from pineapple waste, but this finish is not that good. These are the only molded means by compressing the material into some mold that has been produced. But the limitation in developing these pots, what I have shown in 2 or 3 slides back, they had to develop means the raw material has to be taken directly and that can be developed instantly. They cannot store for a very long time. Where in our study we have developed the pellets that can be used depending upon the requirement of the pots. That is the beauty in our study. So, what are the economic aspects of this study? Major advantage is the cheap and easy availability of waste that can reduce the input cost of plant. And for establishing this waste management plant, that the government of India, I think you people know better, they can give some subsidy of the 50% of initial capital. Maybe I'm not sure, but I have taken this few words from some industrialist person. So a small scale plant that can be made functional within few lakhs. I have means I was in contact with Pushpinder Honey, and we were discussing this point. So, but means if we leave the cost of land, so in 25 to 30 lakhs, this project can be initiated because about 10 lakhs cost will be there for extruder, a basic extruder, not the scientific one. Otherwise, it is about 2 crores or like that, maybe 1.5 crores. But the basic one that can be had for 10 lakhs, and this injection molding machine that can also be developed for 10 to 12 lakhs. So this cost of equipment it may be around 20 lakhs, and raw material is very cheap. Yeah, 25 to 30 lakhs the project can be started. Yes, you're very true. So these are my concluding remarks. Increasing awareness in people like these alarming issues, crop of residue burning, waste dumping in major locality that can ultimately contributing in global warming, and by motivating people to replace plastic products, either it is a nursery pot, household container or packaging. Now people are aware and they are taking alternative to replace this plastic very seriously, and the government is also they are very serious, and they are opening a huge potential of waste based industries. And this growing issue it attracts government to improve the management policy as well as subsidies the entrepreneur to shift their interest in emerging industry.
Great, sir.
And
I think it's a fantastic thing, and we have learned a lot regarding a new technology. I think it can be used in multiple ways, and it can be used in every part of the country, even can be exported outside India, being a completely biodegradable product, as there is a high demand in Europe as well as in America, as in Western world. So I think if we are able to work a bit more and make it more viable and make it more visibly beautiful, then certainly the things can be taken up to the next level.
yes,
And we are very happy, and I'm really feeling proud to have you on board, as you have got some patents and you are working on really new projects. I believe such kind of projects which are happening in SLIET should come over in the alumni arena, so that we can know that our teachers, our institute is really doing something great, and we should be also then we will certainly contribute in one way or the other in order to take these technologies to the world, so that we can have benefit out of it. So in the last, there is one more question from Mr. Vivek Singh. He says, want to know the current campus placement of food tech degree students, and are companies coming to pick students? This is something, from a different perspective, but you can.
yeah, industries are coming, and This year, particularly, we are having some 10 to 12 students, those who are having 3 or 4 jobs in their pocket. So now,
Fantastic.
yeah,
Super.
yes,
This is a
Yeah,
big, big answer, Vivek Singh.
yeah, that's very inspiring, and that's a good news.
Yeah, that's
exactly.
quite inspiring. And I believe this is all hard work of the faculty as well as a connection they are making with the industries. I hope
Yes,
SLIET Alumni Association will be able to make it much better. So I think we have already taken whole of the time. We are still 1 minute ahead of our schedule. So thank you, Dr. Saab, for giving such a fantastic session. Thank you, Pushpinder ji, for coming over. Thank you all the viewers who have come in and all the people who will be joining us in the coming days and watching this video. And I welcome every entrepreneur or entrepreneurial mindset to come in and contact Dr. Saxena in order to make multiple useful things and have really real benefit of these patents which we have worked hard on. Thank you very much.
okay, thank you. Rather, I should be thankful to this SLIET Alumni Association, which is a great platform, and I am really hopeful that industry personnel from our institute, they will come to the institute again, not for their study, but to get the technical benefit for themselves and to help their own younger brothers and sisters. Okay, in the coming day. Thank you very
Thank
much.
you, sir.
Thank you. Thank you.
Yeah, thank